Unless your organization is just getting started, you no doubt have lots of data on premises. And like many organizations, your data is everywhere. It's on servers, local file systems, on a range of file system types and operating systems. It's on network-attached storage. It's in relational databases of many different types: Oracle, Microsoft SQL, Postgres, MySQL. Some of this might even be on staff laptops in the form of text files or CSVs. When we're ready to move to the cloud, how do we get all this data to AWS? We've seen a few ways already. You can always upload data to S3 or add records to Dynamo directly from the AWS GUI, but that's often the slowest way to do things, and certainly the least automated. And recall that if you're using AWS Direct Connect, you can transfer data quickly over the Direct Connect pipe to an EFS file system via an NFS mount. But there are many more ways, of course. In this chapter, we'll explore some of those other options. For instance, command line interfaces for services like S3 have commands that can push, update, sync, and manage data in those services. We'll look at that in the next lesson. After that, it's AWS Storage Gateway, a service that can provide you local NFS mounts that ultimately convey your data over the internet to S3. Next, we'll examine AWS Database Migration Service and Schema Conversion Tool. These AWS features can help you both migrate and, if you choose, continuously replicate local databases to RDS, S3, and more. You're still subject to the latency of your AWS connection overall, but these tools make the move a lot simpler than a DIY approach. Finally, we'll take a peek at AWS's take on SneakerNet, AWS Snowball. This service lets you ship your data directly to AWS, bypassing the internet entirely. We'll start with command line tools in the next video. In this video, I'm in a terminal to demonstrate how the AWS command line interface can be used to interact with S3 and sync large amounts of files to it on a continuing basis. If you don't have the CLI installed and configured, check out my other course called AWS Deployment, Provisioning, and Automation. To get started, we'll type AWS S3 LS to list our buckets. This will let us know that everything is hooked up right. Here we see the 2 buckets that I created earlier in the course. So with that, let's type AWS S3 and then MB for make bucket. We'll type S3:// and then the name of the new bucket we want to create. I'll call this S3 CLI sync and then give my initials to ensure uniqueness. And with that done, we can go back to the console and observe that the new bucket has been created. Okay, I'm in a folder of the course materials called Chapter 5/S3 CLI Demo. And inside here, you can see that we have one big file and a subfolder full of smaller files. You can see we have lots of files there that we want to get to S3. Type cd ... to backup 1 and make sure you're on the same level as big file. From here, we could use the S3 CLI to copy files individually, but we have a better option. We'll type AWS S3 sync and then a dot for the current folder, and we'll specify the name of the bucket. S3:// S3 CLI sync, and then my initials, the fully qualified bucket name. Hitting enter and executing this will send up all these files on a recursive basis to S3, the big file and the subfolder. We can go back to the console and check out the results. Click here and you can see we've got everything that we expected, including all of those smaller files. But how do we know that this is a true sync? Well, let's start by adding another file here. We'll call it hello.txt. Now we've got a new file, and if we execute the same sync command again, you can see that it only uploads the new file that it didn't already know about. And if we head back to the console and click refresh again, you can see that that's true. So you can see how the sync function is very powerful. If you want to make sure a certain folder or files is always synced to S3, a good way to achieve this would be to set up a recurring cron job to run the sync command on the same folder. It will only incur the bandwidth for newly created files. With this, you can use the CLI to stay in sync with S3. We've discussed S3's incredible durability and availability. However, it can be a bit challenging to integrate with other systems, since it doesn't present a traditional file system interface. By default, you must interact with it via RESTful HTTP calls, AWS CLI commands, or via the AWS Web Console. But what if you could make S3 mountable as a file system? That's where AWS Storage Gateway comes in. Storage Gateway is a software appliance you can place in between your data source and S3. Storage Gateway acts as a go-between, presenting a file system front-end to S3 and Glacier Storage. It can be configured to provide file, volume, or tape interfaces. Storage Gateway is smart and will cache hot data locally, so you don't have to go all the way to S3 each time you access frequently used data. And here's where things get interesting. It can be deployed to either EC2 or to VMware. Deploying to VMware means that Storage Gateway can act as a bridge between your existing local data center and the cloud. In a hybrid cloud scenario, you deploy your gateway as a VMware appliance in your local data center. Servers in your data center can now mount a file system on that gateway and seamlessly gain access to cloud storage. You can persist in this mode and maintain a true hybrid cloud, or you can use the gateway as a bridge to AWS, leveraging it as a way to get data to S3 in a one-time migration. Storage Gateway provides a few different ways to present a file system. File Gateway allows the client to mount via NFS or SMB, making it suitable for both Linux and Windows workloads. There's Volume Gateway, which uses an iSCSI interface. Tape Gateway presents a virtual tape library, or VTL interface. Tape storage is often used for archiving data that has very relaxed requirements for access times. As you may have guessed, this type of gateway uses the Glacier tiers of S3 storage for the most infrequently accessed data. Let's dig into the first mode. As a file gateway, AWS Storage Gateway can present an NFS or SMB file system that is backed remotely by an S3 bucket. This file interface can be mounted by any instance that supports these protocols. This can occur entirely in AWS, or the gateway can be on-premises in VMware, making the file gateway a local bridge to cloud storage. Unlike mounting EFS from outside AWS, this model does not require the use of Direct Connect. Within a single gateway instance, you can create one or more file shares. These map to individual buckets and will be your actual NFS mount points. This means that you can potentially serve many different applications and use cases with a single file gateway. You might be wondering how a file gateway handles NFS metadata like file permissions. Permission bits and ownership attributes are stored in S3 object metadata. To provide optimal performance, the file gateway pays attention to what data is used most often and keeps it in a local cache, so hot data can be read and written quickly without incurring network latency. Files are synced to S3 behind the scenes while you get your data without lag. File Gateway does come with a few caveats. First of all, AWS makes it clear that although you're technically able to access the backend S3 directly, you should avoid doing so. The behavior of File Gateway is not well defined when you alter the backend S3 storage and may result in errors or lost data. File Gateway does support using buckets of various S3 storage tiers. However, you should read Amazon's documentation on this, as certain usage patterns can trigger additional fees, such as the infrequent access tier's early deletion fees, or even errors, such as when trying to update files that have been moved to Glacier. For our demo, we'll stick with S3 standard to avoid any of these issues. Other things to consider. File Gateway cannot support symbolic or hard links, so if these features are critical to your use case, you'll need to use another solution. Also, since S3 does not support renaming objects directly, File Gateway implements the operation by copying the affected file objects and deleting the old ones. This means that your gateway won't have to send any additional data over the network, but it also means that mass renames, such as renaming a folder containing many files and subfolders, may not be an instantaneous task. Finally, although the NFS protocol will allow connections from more than one client, AWS again recommends that you do not do this, and instead maintain a one-to-one connection policy between clients and file shares. This will help avoid possible data corruption. If what you need is an NFS file system that supports multiple clients as a first-class use case, you're going to want to look at EFS. However, if your goal is to take advantage of S3's highly durable, relatively cheap storage while avoiding the complexities of interacting directly with S3 APIs, AWS Storage Gateway is a great way to do just that. Now we'll create a file gateway using AWS Storage Gateway. Before we get started, there are two things we need to take care of. First, click into S3. We need to create the bucket that will be the backend for this gateway. We'll go over here to Create Bucket, and we'll call it something like File Gateway Demo. And I'll give it my initials again to ensure uniqueness. I'll keep everything else at the default and click Create Bucket. Now we need to create a security group. Head over to the EC2 section, and along the left-hand side, go to Security Groups. There's a one-time step in the file gateway configuration where AWS needs to access the newly created gateway via port 80. Amazon actually says that as long as this traffic is allowed from my laptop, things will work, and it can be turned off after the gateway is initialized. For our demo purposes, we'll just allow port 80 from the world and remove this access during the teardown at the end. But if it were your production instance, you'd want to allow it only as long as is needed for the configuration. We'll go up to Create Security Group, and we'll call this Allow HTTP from World. And in our description, allow port 80 HTTP traffic from anywhere. Go down and click Add Rule under Inbound Rules, and choose the pre-filled HTTP option, which makes port 80 the default here, and our source will be anywhere, IPv4. That's all we need to do here, so go down and click Create Security Group. Now we can head into the Storage Gateway section of AWS. We'll type that up here in the search bar and click the first option. From here, click Create Gateway. We're going to give our gateway a name, which will be File Gateway Demo. Here below, we have a few different gateway options, including the default, which we'll choose, the S3 file gateway. That's the one that's backed by S3 storage. We also have FSX, Tape Gateway, and Volume Gateway. Under Platform options, you see a few things. This is where we choose the platform for the storage gateway instance itself. If we are running VMware or Microsoft Hyper-V for our virtualization in an on-premises data center, we could choose that option because remember, one of the primary use cases of Storage Gateway is to create a bridge from a local data center to the cloud. For the purposes of this demo, I don't have a local data center. I'm just going to be connecting from within AWS, so I'm going to choose Amazon EC2. Below you see that we've got a button that says Launch Instance and an icon that indicates this will open in another tab. And that's exactly what we'll do. We'll go off in another tab and we'll follow the wizard to create an EC2 that's suitable for the file gateway. But before we do, let's take a look at some of the instructions below here. We're told that instance type needs to be at least M5.extra-large. Now, that's definitely a more expensive instance type than we've used before in this course, so make sure to watch the teardown at the end of this section to make sure you're not charged any more than you expect. We also need to make sure the instance has a public IP, and we need to make sure that it can be accessed through port 2049, which is NFS. We actually already have a security group that allows this from a previous part of the course, so we'll just use that. Finally, pay attention to this section, which specifies that you need to add an extra volume for the cache on this file gateway, with a size of at least 150 gigabytes. AWS recommends we have at least 150 as the basis for the caching disk. They also devote an entire section of the storage gateway documentation to the subject of caching. If you search for managing local disks for your AWS storage gateway, you can find a lot of information on how to tailor disk cache size to your particular use case. All right, let's click Launch Instance. We'll be taken to the EC2 wizard where we'll give our instance a name. I'll call it File Gateway Demo Host. Scroll down and you'll see the AMI has been pre-selected for us. This is the image that Amazon maintains that has the file gateway software already on it. Keep on scrolling down. Under Instance Type, we can type in the search bar M5.x to get the M5.x large that we need. Select that and move on down. For key pair, we'll do something we haven't done before, which is choose Proceed without a key pair. We will not need to SSH this instance as it's fully managed by Amazon. Under Network Settings, you can see that Auto-Assign Public IP is set to Enable, so that's good. And here under Firewall, click Select Existing Security Group. We're going to choose two. We'll take Allow HTTP from the world and NFS from default VPC, which we created earlier. That's been collapsed here under this plus button, so if we click that, we can see that both are applied. Head on down, and here we need to click Add New Volume under Configure Storage. And we'll give this 150 gigabytes. That will be our caching volume. All right, with that, we can go ahead and click Launch Instance. Click the instance ID to see the ongoing creation of the instance. And we can see that this is already in the running state. But we don't want to move on until status checks have passed from initializing to passed. Okay, now that both status checks are passed, we're ready to proceed. Click the checkbox here to see the details of the instance, and click this button to copy the public IP address. Now we'll head back to the AWS Storage Gateway. This tab is where we'll continue to configure the instance. Under Confirm Setup Gateway, click I completed all the steps, and click Next. Here we'll choose if this is a publicly accessible endpoint, and its connection type will be IP. Here we're going to paste the IP address that we just generated. Click Next. All right, review what we've done so far, then click Next. Now Amazon is connecting to this instance to complete the setup. We need to wait for it to look for the local disk so we can decide which one is going to be the cache. So when this loads up, we'll select the 150 gigabyte size disk to be the cache and move on. Okay, Amazon has interrogated our disks and has actually figured out which one is the non-root disk, which is the 150 gigabyte, and it's already set to be allocated to cache. So that's all good. That's exactly what we want, and we can move on. Here under CloudWatch Log Group, we will simplify things by deactivating logging. We'll say no alarm to CloudWatch. These are all things that you would want to set up in a production instance, of course, but not necessary for the demo. We can also skip tags and then click Configure. Something seems to have gone wrong there, but it did not recognize that we selected the cache. So I reselected it, refreshed it, and reselected it, and I'll click Configure. Okay, for whatever reason that seemed to work a second time. Now the gateway is coming up. So we've successfully created the storage gateway. However, we can't connect to it until we first create an NFS file share, which we'll do in the next video. Now that the file gateway has successfully been created, we need to do one more thing: create a file share on it. This will create the NFS endpoint to which our EC2 instances will connect. It's also the step where we'll tell AWS to use our S3 bucket as the storage backend. Remember, though, that buckets are associated at the file share level, not with the gateway. A single gateway can provide a file system interface to multiple buckets for different purposes. Let's check the checkbox next to File Gateway and click Create File Share. Because we checked that checkbox, the first drop-down option is pre-selected for us. Under Amazon S3 location, we'll go with the default, which allows us to connect directly to the bucket without any indirection. Going down a bit, we'll paste in the bucket name from the previous lesson. Here we have the option to give a prefix. This would allow us to place all the files saved through this particular share into a subfolder, paving the way to reuse this bucket for other purposes, using other prefixes in the future. For this demo, we'll leave it blank. AWS region should match where the S3 bucket is. Our bucket is in US East 1, so that works. File share name, we can edit slightly. I'm going to call this File Gateway Share with the initials, and everything else on this screen can stay at default. Click Next. On this screen, we're asked to choose a storage class for the objects. Remember, the backend storage is S3, so it makes sense that we would have the option to choose S3 Standard, Intelligent Tiering, One Zone, Infrequent Access, things like that. For now, we'll keep this at S3 Standard, but it's good to know that you have this option. Encryption, we'll go with S3 Managed Keys, and we'll click Next. On this screen, we have Access Object. This is an option that lets you specify an IP or a CIDR block to which to restrict file system access. Unlike a security group, this is enforced at the file share level, which is why it's part of this configuration wizard. We'll remove this entry for now and skip this step, allowing any user with network access to reach this file share. You can see some other options here, such as root squash, which prevents remote root users from logging in as root on the system. It's a good idea to keep that at default. Permission bits are how the file system will treat files and folders as they are created. We'll keep those at default and click Next. Okay, now we're on the review page. Scroll all the way down and click Create. At this point, we need to give the share a few moments to be created. Right now it's in the updating status. When it's done, we'll be able to mount it to an EC2 instance. Okay, now that the share has become available, let's click into the ID and scroll down past the details. Down here, we see some mount commands that will become useful in a moment. I'm going to copy this first one for Linux. Over here on the terminal, I've logged into one of the EC2 instances from earlier in the course. If you didn't keep one around, that's okay. As long as you have an instance in the same VPC as the gateway, the security group we use will allow it to mount our file share. Let's start by creating a mount point. I'll say sudo make directory, and we'll call it file gateway. Now, before I paste in the command from the previous page, I want to prefix that with sudo again, paste, and then backspace over this mount path, and give the path that we just created. Okay, with that, we can do the df-h command and see our mount right down here. In fact, you can even see the name of the S3 bucket that backs up the storage. Much like with EFS, we see storage space looks extremely large, like 8 exabytes, and if we take off the -h, we'll see an even larger number that struggles to fit on the screen, honestly. Alright, so now we can move into the File Gateway folder. And we can see that we have mounted the file system. Let's create something. We'll echo a little message here into hello.txt. And we can see that file has been created here in the file system. And if we go back to AWS now, we can go to the S3 section and take a look in our bucket. Now you'll recall from earlier that we shouldn't touch any of the backend storage, but we do want to see what's going on here. We'll go into File Gateway Demo. And there you see it, our hello.txt. And you can clearly see now that we have mounted an S3 bucket as an NFS file share When it comes to transferring data to the cloud, especially in very large quantities, latency and bandwidth restrictions are a constant concern. There are many points at which our throughput might be limited by the speed of our connection or bottlenecked by low bandwidth network hops. We can alleviate this somewhat by using a technology like AWS Direct Connect, but at a certain size of data load, the bandwidth of the internet just isn't going to cut it. We'd almost be better off loading our data onto a truck and driving it to AWS. In fact, this is true. Given sufficient data quantity and demanding enough time constraints, physically moving hard drives of data is more efficient than moving that same data over the internet. Back in 1981, American-Dutch computer scientist Andrew Tannenbaum put it thusly: "Never underestimate the bandwidth of a station wagon full of tapes hurtling down the highway." For an interesting dive into the implications of this statement, take a look at XKCD author Randall Munroe's What If article on FedEx bandwidth. For just these sorts of situations, AWS provides AWS Snowball. Snowball is a ruggedized device that Amazon ships to your door via, what else? Amazon Prime. Snowball provides a way to get large quantities of data in and out of S3. You can receive data from an S3 bucket in the mail, or create an export job wherein you'll load data onto a device and ship it to AWS. To get started, you'll log into the AWS console and create what's called a Snowball job. The job consists of a few things. For example, for an import job, you'll specify a shipping address, a destination S3 bucket, and an optional Lambda. This Lambda will be executed for every S3 put performed by the Snowball import job. You can use this to kick off all kinds of processing related to your data import. You will also select a size for your Snowball. The device can be ordered in 50, 80, and 100 terabyte variants. The 100 terabyte size is exclusive to a Snowball variant called Snowball Edge. Snowball Edge is a true edge computing device. Rather than just storage, it allows you to cluster multiple devices together and actually run compute on them via Lambda functions. So you can not only transfer data, but you can perform work. For this series, we'll focus on the normal 50 or 80 terabyte Snowball transfer device. How about security? If you're going to send terabytes of valuable data through the mail, you want to know it's safe. First of all, Snowball requires that you encrypt the data to be transferred. You must select an AWS KMS, Key Management Service, key when you create your job. This key will be used to encrypt the data while it's still on your own device. Then the encrypted data moves to the Snowball, never even traveling with the key. When it arrives in S3, the same KMS key can be used to decrypt. Second, the enclosure itself is tamper-proof and equipped with something called a Trusted Platform module that can alert AWS to any unauthorized changes to the hardware. After your job is complete, AWS erases your data according to the NIST standard for media sanitation. Finally, you can configure SNS notifications for events that occur during the job's lifecycle. This way you can get text messages or emails for things like job created, Snowball shipped, Snowball delivered, Snowball back at AWS, job completed, or job canceled. The Snowball will arrive at your location via 1 or 2 day shipping, your choice. When it does, you'll connect the device to your network and install the Snowball S3 adapter software on your computer. This software comes for Windows, Mac, and Linux and provides an S3 compatible endpoint for you to transfer data locally. Remember, you'll have to specify in advance the target S3 bucket and the KMS encryption key that will be used. When you're done, the Kindle-esque e-ink label on the device updates to the facility that you need to ship to, and you simply ship the device back via your carrier of choice. When you get the SNS notification, you'll know your data is securely in S3. So all this is very cool, but when is Snowball really the best method for getting your data to the cloud? AWS has some rules of thumb in their published documentation. It's really a function of your available bandwidth, amount of data to transfer, and your time constraints. They give some examples in this chart. For instance, on a 100 megabit connection, 100 terabytes could take almost 4 months to transfer. That's assuming you don't run into any connection problems along the way. AWS recommends that if a data transfer over your connection is going to take longer than a week, you're a candidate for Snowball, which is only bound by the transit time of the delivery device. Now, if you have a persistent need to move large quantities of data to AWS from an on-premises data center, it would be cost prohibitive to use Snowball over and over. You're going to want a bigger pipe. Although it's outside the scope of this course, I'd recommend that you do look at AWS Direct Connect, which offers AWS customers a way to tap into high bandwidth networking infrastructure that goes directly to AWS. Another option, of course, is to move your data generating workloads to AWS. Migrating from a hybrid cloud to a full cloud-native solution is definitely going to alleviate many data transfer headaches. There's actually another use case for Snowball, which these days is part of a larger set of devices called the Snow family, as shown here. You can see the specs on AWS's documentation, but they vary in both storage and compute capacity. Why compute? Because the Snow family devices are not just used for shipping data, they're also used for edge computing. Edge computing refers to scenarios where you need a device that can collect and process data, but that must run in an environment where conditions or connectivity make it impractical to work directly in the cloud. Just one example might be a research team operating in a remote location, collecting data with sensors whose output must be processed and stored locally. This team can use a local Snowcone or Snowball device to work with that data, even running an AMI directly on the device, and then ship it to S3 later to continue their work in the cloud. So, whether you're looking at edge computing or a one-time large-scale data transfer, take a look at AWS's family of Snow devices. Oh, and if you've got a really huge data set to move, we're talking exabytes, well, AWS has you covered there too. Meet AWS Snowmobile. It's a literal semi-truck, and if you ever end up needing to ship this much data, give it a try, and please, take pictures. Chances are, if you're interested in cloud data storage, you're not starting from scratch. You've already got a significant amount of data on premises in your local data center or co-location, and you're wondering how to get it to the cloud. Maybe you've been running a relational database, or 2 or 3, for years, and you're ready to let AWS take over the operational details by migrating to RDS. Perhaps you've been running MySQL, and you're interested in the performance enhancements promised by Aurora, or maybe you have some new architectural goals and just want to switch database engines. How do you get from here to there? Well, you have a number of do-it-yourself options. You can use native tools such as Oracle's Data Pump, but often these tools are geared toward homogeneous transfers, not for migrating to another platform. You could use your database's export tools to export data and schemas to SQL scripts and run them. But again, changing engines would mean that you're responsible for translating the resulting output into a syntax suitable for your destination. The files could also be quite large, at which point you're met with the challenges of getting them to the cloud in the first place. Finally, you could export your data in some other format, such as CSV, but then it's all on you to write import scripts that will work with your destination platform. That's where the database migration service comes in. AWS has essentially abstracted away the details of a number of existing migration tools and created a service that gives you a single interface for moving data from one database to another. DMS can do one-time or continuous data migrations to and from a variety of relational and NoSQL databases. It can even move data to S3. Let's take a look at how this works. The key component of a database migration service task is the replication instance. The replication instance is an EC2 virtual machine provisioned by DMS. The host must be able to access both your source and target databases on their respective service ports. For example, port 5432 for Postgres. The replication instance runs migration tasks, moving relational data from your source database to the target. This process can be a one-time event, or you can keep the instance and use it as a persistent replication engine. Just be aware that as long as the replication instance is running, you will incur the cost of that EC2 host, which varies based on the sizing you choose. The two sides of the migration can both be in AWS, or they can be local on-premises databases. The AWS side can be an RDS database, a database running on EC2, a NoSQL database like Mongo or Dynamo, or even S3. This means that you can set up a migration from a local DBMS to a database in AWS, giving you yet another way to move data to the Amazon cloud. When you're ready to go cloud native, you can just point your applications to the remote database, decommission your old one on premises, and terminate the replication instance. Of course, if your target is RDS, you can easily set it up with read replica or multi-AZ functionality to keep that high availability you get from having multiple copies of your database. The data stored on the replication instance itself is encrypted with an AWS key management service key of your choosing. It can be one auto-generated for DMS, or it can be one that you've created on your own. If you need your own SSL certificates, you can also encrypt the traffic to and from the source and target. The other great thing about Database Migration Service is that it not only gives you a way to move data to AWS, it also makes it possible to migrate to a different database engine than the one you're currently using. This is called a heterogeneous migration. AWS provides documentation that makes it clear exactly what conversions are supported. This includes many transactional databases. For instance, you can migrate a SQL Server database to Aurora, MySQL, another SQL Server, or Postgres. Plus, you can migrate many different data warehouse platforms into Redshift. AWS also provides a lot of specific detail on the use of each database platform as both a source and a target. Be sure to read the documentation carefully to make sure you understand the nuances of the migration that you're planning for DMS. To summarize, let's look at the key concepts behind Database Migration Service. First, you'll create a replication instance to connect to both databases and execute the actual migration. Second, you'll establish endpoints, which is just another way of saying you'll set up the connection information on both sides. Third, you'll create a migration task, which can be set up as either a one-time or continuous migration. Finally, within the task, you can set up simple transformations, such as filtering out certain tables or schemas. Let's head to the AWS console to try this all out. Okay, in this demo of the AWS Database Migration Service, we're going to use the existing MySQL RDS database that we created earlier in the course. If you're following along but you don't have that one anymore, feel free to refer back to Chapter 4, build it again, and pick up right here. What we're going to do is migrate from a MySQL database in RDS to a Postgres database in RDS, and we use Database Migration Service to do it. So that means we need to create the destination database. Before we go into RDS and take that step, we need to go into EC2 and create a security group. Scroll down here on the side under the EC2 section to Security Groups, then click Create Security Group. We'll call this Postgres from World. In the description, something like allow Postgres traffic from anywhere. We'll create a rule. We use the drop-down to choose Postgres, because it's in the drop-down here, PostgreSQL, port 5432. Our source will be anywhere IPv4. Now again, that's not how I would set up something in production. I would normally have the database in a private subnet and only allow world traffic through, say, to an application server that can talk to the database. But for our demo, that will work just fine, so click Create Security Group. Okay, now we can type RDS to go into that section of Amazon. And we should see in here our pre-existing MySQL RDS demo once we click on DB instances. So we've got our source system here still running. Now we're going to go create database, and we'll get our target system going. All right, we'll stick with standard create, and we'll choose Postgres under Database Engine. For this, I'm going to choose a known good copy here, one that I know works with this demo, 13.4-R1. It's entirely likely the newer ones will work for you as you look at this in the future, but that's what I'm sticking with for now. I'm going to go to the free tier, just like we did with the MySQL, and I'll start providing some of the identifiers here. So we will match the convention that we used with MySQL, and we'll call this psql-rds-demo for the database instance identifier, and give the username as psql_rds_user. I'll provide a password. Hopefully you still remember the one you used for MySQL. And we'll continue on down. Database class of db.t3.micro is just fine. And here, under storage, we can leave all those at default. Moving on down to connectivity, we want the default VPC and the default VPC subnet group. Here you need to make a change. Public access set to yes. And then under choose existing security group, we'll hit the drop down here and choose our Postgres from World rule. We can also X out the default security group that was chosen for us. We don't have to worry about availability zone, and we can scroll all the way down, leaving everything else at default, and click Create Database. Now, while our target is being created, there's one important step that we can take on the MySQL database. As I said, RDS takes care of the provisioning and creating of your database whenever you stand up a new instance. And that means a lot of the configuration parameters that you would normally have to configure on your own are taken care of by RDS. But what if you need to override them? We'll find out momentarily that when we want to set up continuous replication using Database Migration Service, that the default parameters included in the MySQL parameters aren't good enough for that. We need to make a kind of change. So we'll click here into MySQL RDS demo. Click on the Configuration tab and scroll down a bit. You'll see Parameter Group, default.mysql 8.0. Click it and we'll be whisked away into another part of the RDS console dealing with parameter groups, as you can see on the side here. This is a list of all of the key value pairs that you as a MySQL administrator can modify to change the behavior of the database. It's a long list, and you can see that AWS has helpfully annotated what they do over here on the side. Now, there are two parameters that we're going to need to change to make continuous replication work for us. And you might be tempted to click Edit Parameters, but this is not actually going to be effective for us because this is a default pre-built parameter set. And if we try to save that, we'll get an error. So cancel out of that, and instead go to Parameter Groups from the breadcrumb here, and click Create Parameter Group. The first thing we're asked is what parameter group to base this on. So we'll build off the MySQL 8.0 set that's pre-selected here. And we'll give our group a name. We'll call it MySQL 8.0 so we remember where it's based off of, _ replication group. And this will be description of parameters suitable for continuous replication. Click Create. Oh, our group name needs to contain only letters, digits, or hyphens, so those underscores will not work. We'll have to change those to hyphens. Click Create. Now we have a new group right here that we can click into. Exactly the same as the default, but now we can edit it. Click Edit Parameters. All right, the two parameters that we need to change are as follows. Type up here in the search, binlog benlog_format. This is defaulted to the value mixed. We need to click the drop down and change that to row. Next in the filter, type log_bin_trust, and that should be enough to reveal logbin trust function creators. We're going to set this to 1. That's not strictly necessary for our replication, but it does allow replication to copy over things like functions and procedures, so we want that to be at the 1 value. All right, now click Save Changes. At this point, our parameter group is saved, and all we need to do now is apply it to our MySQL database. So go back and click Databases, click MySQL RDS Demo, and go up to Modify. On this page, we need to scroll down to where we can change the parameter group. It's down here under Additional Configuration. Hit the drop down there, and you see the only other MySQL parameter group, which is ours, the replication group. Click that and scroll all the way to the bottom, and click Continue. We'll see a summary of our changes. It should be just the parameter group. And we have an option, Apply during the next maintenance window, or the one we want, Apply immediately. Click Apply immediately and Modify DB instance. Now, the MySQL instance will go into a modifying state, which you can monitor by clicking into MySQL RDS Demo, going back to Configuration, and watching the parameter group. This is applying. You can continue to refresh the page until this is done, and then move on to the next video. All right, continuing from the last video, we have just applied our custom parameter group to the MySQL database in RDS, and we were waiting for it to go from the applying state to complete. And what we found is that instead the status is changed to pending reboot. So some database configuration changes do require a reboot, and this, it turns out, is one of them. So what we're going to do is we're going to scroll up, we're going to go to Actions, still under MySQL RDS, and click Reboot. Click Confirm, and that'll start the RDS instance rebooting. The next thing that we want to do in this demo is establish a connection between the database migration service and both of the databases. So we'll need to make sure that this is in the available state before we do that. Now, I do think that we're going to have time to type in database migration service here at the top, click into that service, and start up a few things while this database becomes available again. Because the first thing that we need to do here in Database Migration Service is create replication instance. Let's click that button. This is going to create a host that will act as the go-between between these two databases. In this example, both of our databases are in AWS, but they are publicly accessible. And the way that this instance is going to reach them both is through the public internet, through those public IPs that they expose to the world. Now, in your own institution or organization, you might have this database instance reach out to private IPs of both of them because maybe they are not world exposed. Or maybe one of them is on premises and you are talking to it through the public internet and talking to an RDS database in AWS through its private interface. There are a lot of ways that you could do this. But for our purposes, everything's going to be talking through the public internet. So we're going to create this replication instance. And we'll call it Demo Replication Instance, something very simple. We'll skip the friendly name. Give it a short description, a replication demo, and we can leave the instance class at default along with engine version. We don't need multi-AZ, so we can choose dev or test workload, and we can choose for VPC, the only option here, which is our default VPC. So we can have this be publicly accessible, but the instance itself does not actually need to be public. We're not going to SSH to it or anything like that. We're going to configure it from here in the AWS console. So it's going to be able to talk out to the public internet, so it can talk to both of these databases, but it itself, we can uncheck that so it's not publicly accessible. Everything else can stay at default. Click Create. Okay, demo replication instance is being built there. You can see it's in the creating state. You can also see that it got rid of all my capitalization, so all those words just run together in the name, but that's okay, it's still recognizable. What we need to do at this point is create endpoints. So before I do that, I want to make sure that the RDS database is back online. So I'm going to come up here, I'm going to type RDS, and without clicking it, I'm going to right-click on RDS and open that in a new tab so we can keep an eye on it. I'll click into my second tab here and just check the status of that MySQL by clicking on DB instances. And it looks like it's back available, so we're good to go. Click on the first tab. Back here in the Database Migration Service, let's click Endpoints. We're going to tell DMS how to connect to MySQL and to Postgres. So let's create an endpoint. This will be our source endpoint, which is going to be the MySQL, so we'll keep that selected. And it says Select RDS Instance. All right, now that we've got both sides of this connection working, let's head into Database Migration Service and set up the task that will move data from our MySQL to our Postgres. Click on Create Database Migration Task. We'll give a unique identifier here of MySQL to Postgres. Under Replication Instance, we'll choose the one that we created earlier. Scroll down and choose our source database endpoint of MySQL RDS Demo and the target of pSQL RDS Demo. For migration type, we have some choices. We've got Migrate Existing Data, which is a one-time migration, or Migrate Existing and Replicate Ongoing, which is what we want to do. We're given a warning here about the configuration that we have to do to the MySQL database to make it work. And we did these changes already to the parameter set earlier in the course, so we're good to go. Scrolling down to Task Settings, and we can leave this all at the default. You can see some of the behavior that's defined, including dropping tables on target. There are some settings here related to large binary objects, so if your database contains that kind of data, you may want to pay attention to the choices here or click for more info. Scrolling down to Table Mappings. This is where we'll tell DMS exactly what to move from the source to the target. Click Add New Selection Rule. We'll click Choose Schema and go to Enter Schema. That creates a new input here. The percent is a wildcard, which means take everything in the database, and which is what we want to do. And source table name is also a wildcard. If we wanted, we could erase this and put in a specific table name like employees, but we want everything, so we're going to keep the percent. We also have the action to include or exclude, so you can see how you can start to build some sophisticated rules here that perhaps take the whole database but exclude just a certain schema or a certain couple of tables, things like that. So we'll keep that as is with the 2% and include. Scroll down and we'll look here. Under Migration Task Startup, we can choose to automatically start the task on Create instead of manually running it later. So we'll keep that as is and click Create Task. Now at this point, the task is creating, and soon it will go into the running state, and we ought to see the result of the job. Okay, now the migration task has changed from ready to starting to now load complete, replication ongoing, which is what we want. So let's click into the MySQL to Postgres task name, and we can click on the tab that says Table Statistics to see what's happened. Now you can tell right away that putting the wildcard in for the schema might have taken things a little further than we meant to, because not only did we get our schema that we created ad hoc in the MySQL database, we also got all of the sort of built-in administrative schemas. You see MySQL performance schema. I really don't need all of that, and if we were to redo this demo, we would specify just the one schema called My Database, which we created earlier in the course. So when you filter by that, you can see all of the tables that we specified in the SQL that you loaded in. Employees, departments, projects, all that, they have been moved. And so now we can take a look at the Postgres database and see what the result looks like on that side. So over here, I have installed pgadmin, the client to connect to Postgres databases, and established a connection to that RDS database. So you can see I'm already connected here. If I expand databases, I've got Postgres here. And if I expand schemas, you see all the ones that we just saw moved over, including my database, which I can expand. And I can see the tables here, all those that we just saw in the dashboard. If I go to Tools and do Query Tool, I can type in some SQL. So I can say select star from my_database.employees, and I can see that the data has indeed come over. So our migration was fully successful, but this is also supposed to be an ongoing replication. So let's head back to MySQL Workbench, where we are logged in to the source MySQL, and we're going to do one more thing here. We're going to add a new employee, this row right here, Scott Summers. Values are 1. Okay, wrapping up from the previous video, we're looking at our database migration task, and it's time to clean things up. That way we won't see any unexpected charges on our monthly AWS bill. So we're still here looking at the task, the MySQL to Postgres task, and the first thing we want to do is go up to Actions and choose Stop. That'll stop the replication from running. And if you refresh, you see it goes into a stopping phase, and after a moment it will be stopped. Okay, now we can go to Replication Instances and delete this replication instance. These are like EC2 instances, but they don't show up in the EC2 section of AWS, so you got to make sure to delete it from the database migration service. Check the checkbox, go up to Actions, and choose Delete. Click the button to confirm, and we see that we have failed to delete. So this may mean that we still have some tasks running, something that's keeping this thing from being deleted. Let's have a look here. We'll look at database migration tasks. This one is stopped, but I believe we need to delete it. So let's check that checkbox. There we go. Go to delete. Delete that. And when that's gone, we should be able to go take care of the instance. Okay, the task is gone, so let's head back to replication instances, check the checkbox again, actions, and then delete. Confirm with a button, and now we've got deletion in progress. So that's good. We've still got our endpoints here. These will not incur any cost. They're just definitions, but you can delete them if you want to by checking both of them, going to actions, and choosing delete. Now, the things that we do still have around that will incur cost are over in RDS. Type RDS, choose the first option here, and I'm going to start with our Postgres database. So I'll click DB Instances, check the pSQL RDS demo, go up to Actions, and choose Delete. I do not want a final snapshot. Keeping a snapshot around would incur some charges, and I don't really care about the data that's in this database. So I'll uncheck that, and I will uncheck Retain Automated Backups, which causes a new checkbox to appear that says, I acknowledge that I will lose all this data, and that is just fine. I'll type Delete Me to confirm, and click Delete. Now the Postgres database is deleting itself, and that will be taken care of in just a few minutes. Now, if you'd like, even with all the great cloud-native AWS storage and transfer options we've discussed in this course, you're still going to run into systems, be it with a vendor or in your own backyard, that rely on SFTP. AWS Transfer for SFTP is a service that acknowledges that SFTP processes still make a lot of the world go round, but provides a way to make those workloads easier to manage. Many IT organizations have plenty of processes that look like this. A vendor generates a daily batch file of data updates, which it sends to an SFTP endpoint owned by the organization. The organization must then implement scheduled jobs, which monitor the SFTP system for new files and processes them. In this example, incoming data is parsed and stored in a relational database. There's a definite maintenance overhead to this process. The SFTP endpoint, probably a Linux server, must be patched regularly and hardened for security. It is, after all, world exposed so that the vendor can reach it. For each additional job that mirrors this pattern, say another vendor integration, the receiver must either create another SFTP endpoint or configure the existing one to accept another incoming connection. Often this means creating a unique login for each vendor, along with unique destination directories for their files. After all, you don't want different companies sharing the same password or file space, potentially clobbering each other's data or accidentally exposing information. Then there's the question of availability. Creating a horizontally scalable SFTP endpoint is likely more trouble than you'd prefer to take on for something like this, so instead, you have a single point of failure, the host or instance on which the SFTP service runs. If it goes down, the whole pipeline stops. Finally, consider durability. This SFTP service may be using some remote storage, such as an NFS mount, but it's often just using its own local drive. If it's an EC2 instance, perhaps EBS storage. As with availability, the cost and complexity of building the system for high durability is significant, so a failure not only means the pipeline is down, it may mean you've lost data. These are the challenges that AWS Transfer for SFTP is meant to solve. With this service, you can spin up managed SFTP endpoints backed by S3 storage. Combining a managed service with an S3 backend means the resulting system is highly available, auto-scaled, and extremely durable. In fact, the setup of AWS Transfer for SFTP is so closely tied with S3 that it's rather useful to think of yourself as configuring an SFTP access point to one or more S3 buckets. You start by creating a bucket and an IAM role with an attached policy that can access it. If you wish to restrict users to a certain folder path in the bucket, say because you're going to share this bucket as the backend for multiple vendors, you can go ahead and create that folder. Your role policy can be tailored to allow only this path, and AWS Transfer for SFTP can be configured to make sure that's where the user's files go. We then create an SFTP endpoint and add a user to it. When we add the user, we associate the user with a bucket, a role for the bucket, and optionally, a folder path. Then when the user connects to the SFTP endpoint using an SSH key, they're actually interacting with that bucket via the role through SFTP. If you add another user to the SFTP endpoint, you can have that person/account use another folder on the same bucket, or you can actually use an entirely different bucket. This leads to some interesting potential design patterns. You can support many different use cases with just one endpoint, then use bucket and bucket policies to lock things down appropriately. This team of users here can access the endpoint and have their data routed to individual folders on their team bucket. while these cloud vendors get accounts that map to their own distinct buckets, securely separated from the others not only by their own IAM policies, but by the boundary of the bucket itself. So, AWS Transfer for SFTP allows you to take advantage of S3 in some new and interesting ways. Let's go into the console and see how to build one. Okay, our goal is to create an SFTP endpoint using AWS Transfer for SFTP. Before we can do that, we need a few other resources first, starting with the S3 bucket that will serve as the backend storage. Let's go to the search bar, type S3, and then click into that service. On the next page, choose Create Bucket. Go ahead and click that, and we'll give the bucket a name. I'll call it Vendor Dropbox Demo, and then append my initials to ensure uniqueness. Head on down. We will block public access, so we'll leave that option at default. Keep going, leave everything else as is, and click Create Bucket. Okay, now I've got the Vendor Dropbox bucket. I'll click into it. And I'm going to click the Create Folder button. We'll just call this My Folder. And the purpose of this is to be the destination for all the files that will be dropped here by the SFTP user. That way, if we ever wanted to create a different SFTP endpoint using the same bucket, we could route those files to a different subfolder and have separation between the two. Okay, the last thing that I'm going to do before we leave this bucket is go to Properties and copy the ARN, the resource name of this bucket. This button here will copy the ARN to my clipboard. Okay, now the next thing that we need to do is head into the IAM section, because we need to create a policy that will allow our SFTP user that we're going to create the ability to work with this bucket. Let's go up to the search bar and type IAM for Identity and Access Management. Click the first option there. Now we're going to create a policy and then assign that policy to a role. Policies are definitions that grant certain permissions, and once you assign those to roles, roles can be assigned to users or services. So the policy defines what someone can do. It's loaded up into a role, and the role is assigned to a user or service. Click Policies. Okay, we're going to create policy. On this screen, we have a wizard that will walk us through the steps of creating a policy, or we can click this tab and edit JSON directly. Before we do anything here, click your cursor into the JSON, create a few lines here, and paste that ARN of the S3 bucket. That way we've got it handy in just a moment. Now, over here in the terminal, I've opened up one of our exercise files. This is in the Chapter 5 subfolder, and it's called SFTP demo policy.json. Copy that whole thing from bracket to bracket, head back to the editor, delete the existing JSON, and paste this in. Let's take a look at what's going on here. This JSON defines an IAM policy, and it has two statements. You see this here? We've got an array with two statements inside. The first one has an effect of allow, which refers to two actions: get bucket location from S3 and list all my buckets. It's applied to resources AWS S3 star, which means that the recipient of this policy will be able to do these two actions on every single bucket in the account. The second statement has the SID allow specific bucket. The SID is a bit like a description. It has no actual impact as to the effect of the policy, but it works a bit like a code comment. So we can see here from the SID that the intention is to allow privileges on one specific bucket. And you do see the effect is allow, and the action is S3 star, meaning every possible S3 action will be applied to this resource. So this is the part of the policy that will let our user do everything it needs to do in terms of writing to our bucket. So now's the time to copy this ARN, go up here, fully copy what's in between the two quotes here, and overwrite it. We'll do the same on the next line, making sure to leave the /star at the end, so that this policy will allow writing to any subfolder of this bucket. Finally, we want to delete the pasted ARN here at the bottom, get rid of the white space, check over our JSON to make sure we haven't left any unterminated double quotes or commas out, and click Next Tags. Here we don't need to create any tags, so we'll click Next Review. Let's give this policy a name. We'll call it SFTP Reader Policy. And in the description, we'll say, allows access to our SFTP backend bucket. Click Create Policy. Okay, in the next step, we'll create a role, which will be the vehicle for this policy. The role can be assigned, again, to a user or service. Click Create Role. Okay, Our trusted entity type will be an AWS service. In this case, it'll be the transfer service. So we'll go down here to the drop-down and do a little type ahead, and we can choose transfer. Click the checkbox next to that, and that's all we need to do on this screen. Click Next. Next, we want to attach the policy that we just created. So up here in the filter, we can start typing SFTP, hit Enter, and there you see it, SFTP reader policy. Check the checkbox next to it, then click Next. Finally, we'll give the role a name. We'll call it SFTP S3 access role. And for the description, we can leave what's there, but also say, allows SFTP transfer to access our S3 backend bucket. Review everything below, then click Create Role. We've made our description too long, or somehow otherwise violated what can go into the description here, so I'll just backspace over this description, leave what was there to begin with, and click Create Role. Okay, now we have the role, and in the next video, we'll go ahead and create the SFTP endpoint that will use all these pieces. Okay, in this video, we're going to create the SFTP endpoint. Let's go up here to the search bar and type SFTP. AWS has expanded the transfer service to include more functionality, so it's now called AWS Transfer Family. Go ahead and click into there. And on this screen, we'll choose Create Server. SFTP is already populated for us, so we'll keep that as is. And you can see some of the other protocols that are now supported by the service. Click Next. Our identity provider for the server will be service managed, basically meaning that we will be creating user accounts within the AWS transfer part of the console. This is not to be confused with your root account user or any IAM users that you might create. These users will only have access to the SFTP endpoint and nothing else in your account. If you want to choose one of the other options, you could bring your own identity provider like Okta or Auth0. Click Next. Our endpoint in this case is going to be publicly accessible. That's easiest for the demo, but in a production instance, you might want to go with VPC hosted and create something that is accessible through a private network interface. Custom host name, we won't worry about. We will just let the AWS transfer service create a domain name for us. Click Next. Okay, our domain. The backend can be S3 or EFS. We're going with S3, so click Next. CloudWatch logging. We'll let the service create a new role for us through this wizard. We can leave this next option as default, as well as the server host key. Skip over tags, and manage workflows, and just go click Next. All right, look everything over, and confirm by clicking Create Server. Okay, it's going to take a few moments for the endpoint to come online, and while it's doing that, we can go ahead and create a user for this endpoint. Hit the checkbox right here, then go up to Add User. All right, we're going to give this a name like SFTP demo user with underscores there. And for the role, we will choose the SFTP role that we created earlier. So you can start typing here, and you can see SFTP S3 access role. That's the one we created. You see, the transfer service endpoint is a bit like a conduit that connects this user to the S3 bucket. So that user needs to be able to use this role to talk to S3. All right, we're not going to do any additional scoping of the policy, so that can stay as none. And as to home directory, click the drop down here and we'll choose the bucket first, and then type my folder, which was the name of the subfolder that we created in that bucket. This basically establishes the user's home directory in the SFTP endpoint that's going to exist, but this folder needs to be pre-existing when we make this choice here, which is why we created it earlier in the course. Okay, SSH public keys. This user is not going to use a username and password. Instead, much like when we log into an EC2 instance, it's going to use an SSH key. So unlike with S3 that will generate keys for us, we're going to need to do this on our own. So I'm going to head back to my Mac terminal here, and we're going to use a command called SSH-keygen. You might be familiar with using this for other purposes, such as creating a key for GitHub access. We'll say SSH-keygen-T RSA, which is the type of key that we want to create, -B, which is the number of bytes that we want this key to be in size. We'll say 4096, and -C, which expects an email address. Now, this doesn't need to actually be a functioning email address. It's Okay, now that our SFTP endpoint is online, let's try to interact with it with a user that we just created. For that, we're going to need an SFTP client. And I've downloaded one called CyberDuck, which you can find at cyberduck.io. This client is available for Mac or Windows, so no matter your platform, you should be able to follow along if you like. Let's click Open Connection, and then make sure that we change this to SFTP if that's not already the default. We need to type in the URL of the server, which we can get back at AWS by clicking the server ID and copying the endpoint right here, this thing that looks like a URL, and we can paste it right here. Keep port at 22, and then for username, we'll type SFTP_demo_user. Now we won't use a password because, as we just said, we'll use SSH key authentication. So for the private key, if you saved your key in the right place, you should find SFTP demo key there waiting for you. Otherwise, you'll need to navigate to the location where you used SSH keygen to make your public and private key. Just make sure for this that you choose the private key, as that is what is going to get us into the SFTP server. To do that, let's click Connect. Okay, I've established a connection here. If this is your first time connecting to the SFTP service, you may also be asked to accept a fingerprint, much like you do when you first log into an EC2 instance. Just click Allow and go on through. Alright, now here I am at the root of the SFTP endpoint. You can see that I have the bucket name right here, the S3 bucket name, followed by my folder, which means I'm in the home folder of this SFTP demo user. Now from here I can upload, download, delete, and do all the file interactions that I might want to do with any SFTP endpoint. And to demonstrate, I've got this AWS logo file sitting right here. I'm just going to drag and drop that onto the surface. And with the upload complete, I'm done. To verify that this worked, let's go back to AWS, go to S3, click the link, find our Dropbox bucket, click into it, then my folder, and there it is, AWS logo.png. So that file made its way all the way through from the SFTP endpoint to the bucket. So you can see how using AWS Transfer for SFTP, you can create an SFTP endpoint that behaves like any other you've ever used, but that's backed up by the durability and availability of S3. Okay, let's go ahead and clean up the resources we created with the SFTP demo. Click into AWS Transfer Family. We'll start by deleting the SFTP endpoint. Here it is, click the checkbox next to it, go up to Actions, and choose Delete. Confirm by typing Delete and click the Delete button. That'll take the endpoint away along with the users that were created underneath it. Next, let's go visit CloudWatch. Click the first result, CloudWatch, and we'll see the logs that were generated by this SFTP activity. Expand logs and go to log groups, and you'll see one here for the AWS Transfer Service, along with a few log entries that were created by the activity that we just did. Go up to Actions, and you can delete log group. Next, we'll go to S3, and we'll delete the bucket associated with the Dropbox. Click Vendor Dropbox. First, hit Empty. Type permanently delete. Throughout this course, we've talked about a few different ways to send and sync data to the cloud. If you've tried this on your own, you know that you can be subject to the whims of the network between your source and destination. It's vital to have a tool that can not only maintain a high level of throughput, but also one that's resilient and can handle interruptions along the way. That is the purpose of AWS DataSync. It can take data from locations inside or outside of AWS and get them to the cloud reliably and quickly, pulling from sources like NFS, CIFS, or Hadoop file systems. It can be run ad hoc or set up on a schedule where it will sync new files as they appear in your source. Your destinations can be any one of the FSX file system types, an S3 bucket, or an EFS file system. A common use case would be to get data from a location in your on-premises data center into the cloud. In this case, you'd run an agent VM locally, close to the data. For this, Amazon provides images to build the agent in VMware, KVM, and Hyper-V variants. DataSync can also be configured to move data from object storage in other clouds, namely Azure Files or GCP storage buckets. Another supported use case is transferring between AWS services, perhaps across regions. This method requires no agent at all. Nice. Since we can try this using only the AWS account we've been using for our goal here is to move data from EFS to S3 using AWS DataSync. To show that, I've logged into an EC2 instance that I've stood up here with an EFS file system mounted. If you want to replicate this, you'll remember that we did this back in Chapter 3, so you can go back and follow those instructions. In here, I've got a little bit of data, and this is replicated from the way that we set up the data for demonstrating S3 CLI syncs back in the beginning of this chapter, second chapter of Chapter 5. So you'll see that we've got one large file called Big File and a folder with many small files. These are in Chapter 5 of the exercise files, but there's also a Ruby script in there that will generate them for you if you would like to do it that way. All right, so we've got our EFS and we've got some data. Our destination is here in S3, our demo bucket, which has a few objects in it already, and we'll create a subfolder in the course of syncing data over for all the EFS data to land. All right, let's use the search bar to head to the DataSync section of AWS. To get started here, we choose a use case between on-premises and AWS or between AWS storage services. We're doing the latter, so we'll click that and go right into the wizard. This is going to walk us through a few steps. If you expand the menu over here, you'll see some of the things that we mentioned in the slides about setting up locations or agents, but we'll just walk through it. We'll create a new location for the source. That will be an EFS file system. The region is wherever you set up your EFS. Mine is in US East 1, so the drop-down will show the EFS I called DataSync Demo. So for mount path, this is not to be confused with the directory that we use to mount the EFS on our EC2 instance. So it's not /EFS. I want to just refer to the root of the EFS file system, so that'll be a /. As for subnet, I'm going to choose one where I know I can reach the EFS from. Remember, if you follow those directions, all of your access points in the EFS should have a security group on them that allows NFS from anywhere in the VPC. And I'm going to choose that security group right here. Before we do that, I'm going to choose in-transit encryption TLS. It's a little surprising, actually, that this would not be a default option. You always want to have your data encrypted in transit when you're making a move like this, especially over the public internet, which we're doing in this demo. The two optional settings here can stay at their default, and then we click Next. All right, now we are setting up the destination. So we'll create new location. We'll choose S3, the region where your bucket is, and I'll select the bucket in this dropdown. Storage class is standard, and the folder we can create here. So I'm going to call this DataSync Demo. For the IAM role, click the Auto Generate button, which I've already done, so you can see an IAM role name there. Once it's generated, go ahead and click Next. And now we've got two locations. We'll create the task. We'll call this DataSync Demo. And take a look through the options here. You can see that there is a step here where DataSync will verify that the data was transferred correctly. You can see you can choose here whether to scan the entire source for all files or if you want to drill down into certain locations. We'll keep those at default. I'll not put this on a schedule, but of course you can set up any schedule you like, including a custom schedule, to sync this data as often as you want. For us, we'll kick it off manually. No tags necessary, and we do want the default CloudWatch logging going on here, so keep that at default and click Next. All right, scroll down, review your choices, and click Create Task. Now, we didn't give this a schedule, so as soon as task status is available, go up here to Start and click Start with Defaults. That'll change the task status to running, and if we want, we can click See Execution Details here. So we're in a launching phase now, and in a few moments, this will be complete. Okay, now we have a success message, so let's head into S3 and see the result. I'll click into our bucket here, and we see the subfolder DataSync Demo and all of our files in here. Now, if we had made this into a scheduled DataSync job, it would continue to run on that schedule, and like the sync command in S3's CLI, it would recognize the changes as they're made. It doesn't resync all the files, it just looks for things that have changed since the last run. So whether you are coming from an on-premises file system, or from another cloud's storage provider, or from another service in AWS, DataSync is a really great way to move files around. It runs things in parallel as much as possible, it's high performing, it handles interruptions and blips in the network, works very well. Just another great way to get data into the cloud. Okay, picking up from the last video, we'll do our cleanup here. So here in the demo bucket, you can delete everything from here and then delete the bucket, but this bucket continues to be used in the core, so I'm going to keep it around. I will go ahead and check just this checkbox here and click delete to get rid of the DataSync demo folder. I'll confirm by typing delete and click the delete objects button. From here, I'll head back into DataSync. So all I need to do here is highlight the task, Go up to Actions and then Delete, which I can confirm. And then go to Locations, highlight and delete both of those. None of these definitions AWS Glue is a fully managed serverless data integration service based on PySpark, the Python implementation of Apache Spark. With Glue, you design data flows by connecting sources to targets with transformations in between. The Glue wizard and GUI help you define these jobs, which generate PySpark code. If you're already familiar with Python and Apache Spark, you'll be right at home. If not, Glue can get you started by proposing designs for some simple ETL jobs. Because Glue is serverless, although you pay for the resources consumed by your running jobs, you never have to create or manage an EC2 instance. Another core feature of Glue is that it maintains a metadata repository of your various data schemas. This could be relational table schemas, the format of a delimited file, and more. Although it is sometimes confusing, Glue calls these metadata repositories databases. You can define a schema in one of two ways. First, you can manually enter it. This would involve you typing the name of each data column or field, then specifying its type and data width. Alternatively, Glue can search your data sources and discover on its own what data schemas exist. To do this, you must define what's called a crawler. Crawlers can read from S3, RDS, or a JDBC source. They can discover table schemas, but do not discover relationships. And they can be scheduled to update themselves over time. With crawlers keeping your metadata up to date, mapping source data to destinations becomes fairly straightforward. Keep in mind that existing jobs are not automatically aware when schemas change and may need to be refreshed. Jobs can be triggered on a schedule, such as daily or monthly, on completion of another job where we chain dependent jobs, or on demand. Finally, a few caveats with Glue. Unlike many popular ETL packages, it has no third-party connectors. You're not going to be connecting to Salesforce out of the box with Glue. As I mentioned earlier, when schemas change, you'll need to update the jobs that use them. Chaining dependent jobs is possible, but job change In this demo, we're going to create a job using AWS Glue that moves data from a CSV stored in S3 to a table in our MySQL database. If you didn't keep or create the MySQL demo from earlier in this course, you can do so by reviewing the Chapter 4 video called Create a MySQL RDS Instance. In addition, we're going to need an S3 bucket. If you've still got the demo primary bucket from back in Chapter 2, that's perfect. Otherwise, take a moment to create a new one with the same default configuration that we used in that chapter. I'm going to go into S3 and into my demo bucket, where I've got a file called states.csv. This exists in the Chapter 2 folder of the course exercise files. And it looks like this. Very simple. We've got the name of a state, the abbreviation, the year it became a state, the capital, a few other bits of information here. And that's it. Just a couple of columns, a row for each one of the 50 states. Okay, so make sure that that's in your bucket. And now let's go to the search bar and type Glue. We'll go here to AWS Glue, and on the next page, instead of clicking Get Started, we'll come over here to Crawlers. Okay, we're going to create a crawler that will look at our S3 bucket and identify the schema of all the files inside. So click Create Crawler. We'll call this Demo Crawler. First, it'll examine the S3 bucket, and then later in this part of the course, it'll look at an RDS database. Go ahead and click Next. We're asked, is the data already mapped? And the answer is not yet, so keep that at default and click Add a Data Source. Okay, we're choosing S3, which is the default. We can skip the network connection option and go to the location of S3 data. That's in this account, and we could type in the S3 bucket name, or we can click Browse. Okay, do not click into the bucket, but rather click the little radio button next to the bucket and click Choose. Okay, if you click off or tab off of that, the error message that you just saw should go away. And you can see below a couple of options for how the crawler should work. We'll keep that at the default to crawl all subfolders. Click Add an S3 data source. Okay, click Next. And now we need to create or choose an IAM role that will be used throughout the Glue process. Right now we don't have one, so we're going to click Create New IAM Role. And we're prompted to add a suffix to an existing name. So I'll just put my initials on there and click Create. Okay, so an IAM role has been created for us, and we can go ahead and click Next. Now we need to choose where the output of the crawler should go. That metadata is going to end up in something called a database, which is a little bit of confusing terminology, but it's just the location where that schema information will get stored. We don't have that kind of database yet, so we're going to click Add Database, which opens in a new tab. We'll call it Demo Metadata. Leave the other fields blank and click Create Database. We're being told it needs to be lowercase letters, so we'll call it Demo Metadata like this. Click Create Database. Okay, we can close this tab now, and back on the original tab, hit the refresh button, which will cause our demo metadata to show up in the dropdown. Now click Next. Okay, review all the options. Scroll down and click Create Crawler. After a moment, the new crawler will appear. Check the checkbox next to it, and we'll go to Run. This process takes a few moments, but what's happening is that the crawler is now inspecting our S3 bucket. It'll look at every file that it encounters and try to take a look at it and understand what its schema is, which it will save in the database that we specified. Okay, now that that has finished and succeeded, we can go over here on the side to Databases, click into Demo Metadata, and see that we have two table entries right here in this section. The first is from the Parks and Landmarks Detroit file that was in the S3 bucket alongside states, and the second is the one that we're interested in, states.csv. You can see it's been renamed. Our target for this demo is going to be the MySQL RDS database. But before Glue can connect to it, I need to do a little explaining. Imagine this box here represents all of AWS. Not just your resources, but mine too, and all those belonging to AWS behind the scenes. Now, most of the resources we've created in this course have been built inside our default VPC. A VPC, or Virtual Private Cloud, is like your own data center inside AWS. It's an enclave where your network traffic is private and enclosed, much like your on-premises data center may be. Since VPCs were introduced, AWS has designed most of their services, including RDS, to work within a VPC. You can see our database here inside the VPC. The thing is, some AWS services exist outside of any VPC and need special steps taken to establish communication to your private resources. S3 is actually one such service, although AWS does an admirable job of hiding that complexity. Normally, you don't have to think about it. Another service that's outside the VPC is Glue. Now, anytime that we set up a Glue job with a connection to a VPC resource like this RDS database, Glue is going to create a network interface inside our VPC that will be used to run our job. This is basically a little worker node or job runner for the Glue job. So in order to let Glue both talk to our RDS database and communicate with S3, which, by the way, it would need to do even if our source was not S3, we need to do two things. First, we need a security group that lets the worker talk to RDS. This will take the form of a self-referencing rule. This is a security group that fully trusts any resource bearing that same security group. It doesn't trust, say, an IP address or a CIDR block. It trusts the ID of another security group. In fact, it trusts the ID of itself. We'll attach this security group to the RDS, and later, Glue will use it when it tries to talk to the database, so it will be allowed in. The second thing we need to do is give the Glue job a way to talk to S3 from within the VPC. We'll do this by creating something called a VPC endpoint. Specifically, we'll create a gateway endpoint to S3, giving Glue a private channel to the S3 service. Although it is possible for Glue to reach S3 through the public internet, Glue uses the VPC endpoint to keep all job traffic within the AWS network, instead of going outside to the public internet. If all this sounds a bit confusing, I don't blame you. It's a fairly big hurdle to usability that one needs to understand so much of the internal networking, not just of their own resources, but of AWS itself to configure Glue jobs properly. Right now, the only real way to understand them is Alright, let's take the steps necessary to get AWS Glue talking to our RDS database. Remember that I'm assuming that the MySQL you created in Chapter 4 is still around. If it's not, head back there and look for the video called Creating a MySQL RDS Database. When you're done, let's head back here into EC2. Along the left-hand side, we'll look for security groups. We're going to create the self-referencing rule I mentioned in the last video. Click Create Security Group. Now this will have to be done in 2 steps because after all, we can't reference this rule until the rule exists. So, type in a name, we'll call it Glue Self-Referencing Rule, and I'll copy-paste that into the description. We're not going to do anything else. We won't add inbound or outbound rules, we'll just click Create Security Group. Now here on the summary page for that rule, we can click Edit Inbound Rules, and now we can reference itself. Click Add Rule. Under Type, choose All TCP. Keep Source as Custom, and click into the text box with the magnifying glass. We'll type the word glue to filter down to this rule. And now, this rule is referring to itself. It will trust any traffic coming from any resource in AWS that also has this security group attached. Click Save Rules. Okay, now that we have the rule, we want to head to the RDS section of AWS. Type RDS and choose that option. We need to attach this security group to our RDS MySQL database. Click on DB Instances and click on the name of our MySQL database. Click the Modify button and we'll scroll about halfway down the page here once it loads to right here under Connectivity. Hit the drop down by security groups, type Glue, and we'll choose the self-referencing rule. Make sure that appears below, scroll all the way down, and click Continue. Here in the summary, make sure to check Apply Immediately. That way we won't need to restart the database. Click Modify DB Instance. That's going to take a few moments to take effect. Our next step is going to be in the VPC section. So I'll search that and click into VPC. Over here on the side, I'm going to Endpoints. Now create endpoint. Alright, we'll just call this demo endpoint for now. Keep AWS services clicked here, and go down and filter by the words S3. We'll choose this middle one, com.amazonaws. And then the name of your chosen region, .s3. Okay, there's a global one here and one for Outpost, but we'll choose this one in the middle. Now we have 3 more options, and the one we want is the type of gateway. So make sure that is checked. Scroll down, choose your default VPC out of the drop-down, and scroll down a little more. Very important step here, make sure to check the checkbox next to the route table that appears so that AWS will modify your routes to use this endpoint. And that should be everything you need, so scroll all the way down, then click Create Endpoint. Now that we've done those 2 things, we can head back to the Glue service. And on the side, we can go to Connections. That'll open up in a new tab. There's a lot going on this screen, but just scroll past anything that refers to connectors and go down to Connections. Click Create Connection, and we'll call this one MySQL Connection. Type is going to be Amazon RDS, and database engine is MySQL, of course. Down here, we'll choose our RDS instance from the drop-down, and that pre-fills a few values for us, including the database name of my_database, which we created in Chapter 4. Remember that, as it will come in handy in a few steps. Our username is pre-filled, but we'll need to type in our password. Click Create Connection. Now, AWS has been making a lot of enhancements to Glue over the past few months and years, and unfortunately, in so doing, they have lost a pretty useful button. There used to be something that would let you just test the connection from here. Fortunately, we can get back to it. If you type in Glue and go back to the front page, you may see this Legacy Pages section. Scroll down and click Connections Legacy. Now, this is just an older user interface, but it does have this nice, useful button here. I'm going to click MySQL Connection, click Test Connection, choose the IAM role that we created earlier, and click the Test Connection button. Now, when you're watching in the future, it's possible that Legacy Pages section will have been fully retired, and you'll We're picking up right where we left off with Glue, now able to talk to the RDS database. Over here in MySQL Workbench, I've logged into that database, and you can find this bit of SQL in the Chapter 6 folder of the exercise files. It's in a file called MySQL statestable.sql. You see, speaking of features that Glue has modified or taken away, one of the things you used to be able to do is set up a job that would create the table in the destination database. Unfortunately, Glue isn't going to allow us that option right now, at least not through its graphical editor. So instead, what we're going to do is create the destination for our data, and then have a crawler in Glue discover it, so that we'll have both sides of the metadata defined. In this case, you can see that this table is not going to be exactly like the schema of our CSV file. And that's because we want to show a little bit of transformation happening in this ETL job that we're going to define in Glue. So what we'll eventually end up doing is mapping state to state name, abbreviation to abbreviation, and then we'll do a little bit of concatenation between the capital and the name of the state so that we can show a very basic transform that changes the data as it moves from S3 to the RDS database. So to get this table created, we just highlight it and click the lightning bolt, and then we can head on back to AWS. Now we're going to go back to crawlers. We could create an entirely new crawler and database, but we're actually able to use the same one that we used to crawl S3. Click into Demo Crawler, scroll down to Data Sources, this tab here, and then click Add a Data Source. Now we'll choose JDBC. That's the protocol that Glue is using to talk to the database. As for connection, hit the drop-down, you'll find MySQL connection. Here in include path, a very important step, type my_database. Now this does rely on you having set up the RDS database just like we did in Chapter 4. I wouldn't recommend using the % here, or at least in my experience that has led to errors, but being specific with the schema path here should work for you. Click Add a JDBC data source. Okay, now we can click Run Crawler. And to watch the progress, we can click back on crawlers again. Now what's happening here is that the demo crawler will rescan everything that's in the S3 bucket. Having found nothing changed, it won't make any modifications to those tables. Then it will look at the RDS database in the schema My Database and describe the schema for all of the tables that it encounters there. Okay, a few minutes later and the crawler is done and has been successful. So let's click over to Databases, into Demo Metadata, and now we see we have more tables than before. In addition to the 2 CSV files from S3, we have several records of database tables from Now that we've got Glue talking to both S3 and the RDS database, and having established a metadata repository of files in S3 and tables in RDS, let's go into AWS Glue and click on Jobs. This will open up a new UI in a new tab. Under Create Job, we've got a few options. The default, which we'll go with, is Visual with a Source and Target. This will create a template for us using Glue's drag and drop interface. But you can also see we can start with a blank canvas or go straight to editing scripts with Spark, Python, or even a Jupyter notebook. Our source is S3, and our target will be MySQL. This will just let Glue know a little bit about what we're doing so that it can generate some boilerplate code for us. Click Create. Now on this page you can see that we've got a visual representation of a basic ETL job. You can click on the first node here. This is a source node, and it says S3 bucket. Still, we need to choose the location from either the data catalog or S3. So we'll go to the database here, keeping data catalog selected, and choose our demo metadata. This will allow us to specify the table states CSV. Even though it says table, remember this is a representation of the schema of our CSV file. So you can see if you click Output Schema, because we have that metadata, Glue knows about the columns that exist here. Now we can go to the data target and choose the other end. The database here will again be demo metadata, and the table will instead be My Database States. Again, we see the output schema matches what the metadata crawler found. In between here, we have Apply Mapping. Now, if you're familiar with other ETL tools that use a drag and drop interface, I think you're going to find this a little bit limited. We don't have the ability to directly map column to column with this interface knowing about both sides. Despite the fact that we have the crawler information and all of the schema for the source and target, we don't really get to connect the dots in the way that you might with other systems. So we do need to know a little bit about what Glue is expecting here. So we have this option drop, and we can go ahead and click that for all the columns we know we are not going to map over. We're going to leave just state and abbreviation, and we'll deal with the concatenation of capital and state later on in code. Here we have source key and target key. And again, we have to know about both sides of the metadata. If you want to click over to MySQL, you can review that by clicking Output Schema and see that the column is called State Name instead of just State. So here under Apply Mapping, we'll replace the target with State Name. If we were to run the job just from here, Glue would map over the state and abbreviation into our database table. But we want to do a little bit more. And before we run the job, we need to supply a few details. Go to job detail and give the job a name. We'll just call this demo job, and we need to fill in this IAM URL down here, which you will recognize from generating it earlier. Everything else here can stay the same. Now we can click Save on the job. And again, we could run it from here, but let's do a little bit more. Go to Script, and you can see the PySpark code that Glue has generated out of this visual template. I will say that the drag and drop interface of Glue is quite limited and a little bit confusing. It's much better, I think, if you let it set up some boilerplate and then edit the code directly. So to get the most out of Glue, it helps to know a little bit of this code. Let's take a look at what's going on here. We've got some import statements at the top. We've got some setting up of variables based on the parameters that we configured outside in the GUI. And we've got three kind of sections of code here that represent the three nodes on the graph we were just looking at. We create a dynamic frame out of the demo metadata states.csv metadata. We have apply mapping, which has a mapping for state to state name and abbreviation to abbreviation. And then at the end, we have a statement here that writes into the dynamic frame represented by the states table. So that's the whole job. But if we want to do the concatenation for the capital, we're going to need to go to another exercise file. In the Chapter 6 folder of exercise files, you will find this. It's called glue states concat.py, and there's just a few modifications here. First, we have a new import statement that pulls in a couple of functions that we're going to use, concat, lit, and call. Here, we say temp data source equals, and we create a new data frame. We're starting with the S3 bucket, and we're adding a new column. We'll call it capital concatenated, and then you can see we are concatenating the column capital. We're concatenating a literal, which is a comma and space, and then we're concatenating the state. So it doesn't actually matter whether we use capital in the mapping, even in the visual or in the code here. Instead, we are creating a new column before we ever get to the point of apply mapping. So we create a new data frame out of that dynamic frame, print schema just for a little debugging purpose. And then here, I've added a new line to the apply mapping to make sure that capital concatenated maps to the same name column in the destination. And that's it for changes. If you copy this entire script, we can head back to the AWS console and put it in. Click Edit Script. Now we're warned here that doing this will force us to abandon the drag and drop mode of editing the script, and that's okay. Click Confirm. Now we can highlight and delete everything and paste in the modified script. Click Save, and now click Run. Okay, follow the link here to run details, and we can see that we're in the running state. If you want to watch any logs while or after this is running, just click here in CloudWatch and that will open up in a new tab. We'll let this run, and in a moment we can inspect the Okay, as with everything in this course, we'll clean up after ourselves so you don't incur any unexpected charges. We'll start here at the dashboard of AWS Glue, and we'll go to the Jobs section. Highlight the demo job name by clicking the checkbox, go up to Actions, and choose Delete Jobs. Click Delete to confirm. Okay, expand the menu here with the three lines, and go to Glue Catalog. That'll open up in a new tab. Let's go to Databases first. Check the box next to Demo Metadata and hit Delete. Confirm that with a button, and that will take care of all of our metadata and the database that enclosed it. Now we can go to Crawlers. Check the checkbox, go Actions, and then Delete Crawler. That will take care of the crawlers and their data connections, except for the connection to RDS, which is here under Connections. Another new tab opens. Scroll down, choose MySQL connection, go to Actions, and Delete. Okay, now let's think about the things that we had to do to the RDS database. To start, we'll go to VPC and delete the endpoint. Click Endpoints. Click the checkbox next to Demo Endpoint, go to Actions, and then delete VPC endpoints. We'll type Delete to confirm. Now, here in RDS, we're going to make things simple. Instead of detaching the security group, at this point in the course, we are done with this database, and we will fully delete it. You'll want to go ahead and do this for any RDS that you might still have around. Click the checkbox, go to Actions, and then Delete. Here you'll have to answer a few questions. Say no to Final Snapshot, because we don't need this data, and a snapshot could sit around and incur some charges for you. Do not retain automated backups, and do acknowledge that all this data is going away by checking the third box. That Delete Me to confirm, and click Delete. Okay. At this point, you could delete the security group that we created, the Glue self-referencing rule, or go clean up IAM policies, but none of those things are going to charge you. Okay, from here, we'll go into S3. And you can delete this generated S3 bucket that's owned by Glue by checking the box next to it, first clicking Empty, and typing Permanently Delete, or you can cut and paste. This will empty out anything that Glue placed in there while it was running. And when that's successful, hit Exit, check it again, and choose. Throughout this course, we've explored many ways of using AWS services to store and manage your data. And at each stop, we've looked at how to keep that data backed up. After all, there are many potential threats to your data. Disk failure is one. While AWS's high level of advertised durability, facilitated by behind-the-scenes replication and integrity checks, makes this possibility a remote one, remember that not every service has the same level of durability as S3. EBS volumes will beat an off-the-shelf hard drive any day, but they're still subject to failures. Malware is another danger. Any AWS stored data attached to an instance with internet access is subject to the same malware risk as any PC or laptop. A very real, very scary possibility these days is that ransomware could encrypt your data and hold it hostage until you pay up. You don't want to get stuck having to comply with a demand like that. Finally, there's the most prevalent danger to your data. You, or your users, or your newly released, we definitely tested all the edge cases, didn't we? Application feature. I'm talking about accidental data loss, or data corruption, the kind of thing that's hard to plan for because it is by nature a surprise. In all these cases, a good backup strategy can turn potential catastrophe into an IT win. So of course, it's important to have backups. That's why with every data storage service we've discussed in this course, we've touched on the subject of creating and restoring backups. For better or for worse, the method varies from service to service. EBS has snapshots, DynamoDB can be backed up to S3, RDS has its own snapshot capabilities, as does Storage Gateway. And at first, EFS didn't even have a way to back up. When the service first launched, you were responsible for doing your own backups, say by scripting and scheduling an ETL job and storing the backup somewhere on your own. So you can see that managing backups in AWS can mean working with a fairly disjointed set of tools and processes. This scenario is not unlike the state of AWS command line tools was a few years ago. At that time, it was not unusual for individual AWS services to have their own command line tool, which would be installed separately from each other. These interfaces were not always the most consistent because different development teams created them independently of each other. Eventually, AWS made a concerted effort to rectify this situation, leading to the single AWS CLI we enjoy today. The unified CLI still lets you work with all the many different services that comprise AWS, but it provides a one-stop shop for doing so. Similarly, AWS Backup is a service that aims to bring consistency to the experience of managing and maintaining backups in AWS. It takes those disparate implementations of backup that I just mentioned and provides a one-stop shop to manage them. AWS Backup establishes a consistent, centralized management interface for backups across multiple services. It debuted with support for EBS, RDS, I'm logged into an EC2 host that has an EFS file system mounted. Let's take a look at what's inside. All right, we've got a couple of files here, text files. We've got data in JSON format. And, what's this? We've got very important documents. Inside here, you can see annual budget, final report, some things that look like we really wouldn't want to lose them. So to protect ourselves against the risk of accidental deletion, let's go to AWS Backup and create a backup plan. Back here to the AWS console, and we're going to type backup into the search bar here, and click the first result, AWS Backup. Now we'll click Create Backup Plan. What we'll do now is define our plan in two steps. The first step is to set up a plan that defines the timing, frequency, and retention for the backups that we're going to create. Then we'll take that plan and assign to it resources like the EFS file system that we just looked at. Now we can start with a template, and we can choose from some common patterns of backup here. Or for this demo, we can click Build New Plan. We'll call this My Backup Plan, and scroll down to Rule Configuration. Our first rule we'll call Daily Backup. For the backup vault, we can click to create a new one, or we can select an existing one from the dropdown. So there's a default that should be pre-created that we can build. This one here could use some explaining. When I first created the EFS file system, it actually gave me the option to establish backups using AWS Backup right there at the creation point of the EFS. So this is actually a vault for an existing backup plan for this EFS. But just because AWS has given us that convenience over in the EFS part of the system doesn't mean that we can't come in here and create our own custom backup rules for this or any other file system. So we'll go ahead and just choose the default here and continue on. Backup frequency is already set to daily, but you see you have every option here, including custom cron expression. So if you're familiar with cron, you can create a command that gives a very detailed frequency for this backup. If you'd like to enable something similar to what we saw with RDS, where you can have a very fine-grained recovery point going down to, say, the minute, you can click this to enable continuous backups for point-in-time recovery. That will incur a little bit of extra cost for you, but it does mean that you have a whole lot of resolution as to where you can target your backups. Can be very nice. We'll leave it unchecked for now and continue on down. The backup window says, when will this backup occur? You can see the default is 5 a.m. UTC, or you can click Customize Backup Window and give your own time. We'll keep the default for now. Now we have some transition rules. We can choose to transition to cold storage, never, or after a certain amount of days, weeks, or months. For these daily backups, we'll keep them for 2 months before going to cold storage. As for retention, this gets to when the backups will actually be finally fully deleted. So we'll say these daily backups are going to stay around for 6 months. And you might be thinking, well, I want my backups to stay around for longer than that. We're going to supplement this rule with a different rule that takes snapshots at a different interval and keeps those around for longer. Of course, all this configuration means you can tune your backup plan to exactly how you'd like it to work. The other thing to note here is that there needs to be 90 days between cold storage and final expiration due to the limits of S3 Glacier, because these backups, like many things in AWS, are being stored in the backend by S3. And so the lifecycle policies we're configuring here are really S3 object lifecycle policies. So when you say cold storage, that's transitioning to the S3 Glacier tier, and expiration means actual deletion. We don't need to worry about copying to any other region or any of the other options on this page, so click Create Plan. Okay, now we're into the second phase of creating the backup plan, which is assigning resources. The resource assignment name we will call EFS Demo Assignment, because we're just going to assign the one EFS. And as far as the IAM role, we can keep that at default. And scrolling down. We can either include all resource types, which is very expensive, protect all resource types enabled in your account, or we can get specific by checking the second option here. If we select resource types, you'll see we have different types of resources that we can protect, and we can assign multiple different types at one time. These are all just checkboxes we could check. And the same frequency and retention model of the backup plan that we created will apply to all these resources. In this case, we'll just go with EFS here. Once we've selected that, we get another option here to choose the actual EFS, and we're asked for an ID, but luckily this dropdown is going to allow us to check those off individually. It will load the file systems that are known to the system and allow us to select those. So we've got our EFS file system established here. If we had a more expansive rule, we could come here and exclude certain things. So we've got a lot of options here as to how we can target the backup to just certain resources. In fact, in this last part here, we could skip entirely the selection of resources based on type and do it based on tags. And tags are a very powerful way in Amazon to focus on certain resources, whether it's for your cost reporting or for integrating with a third party that does things based on tags. That metadata that you can put on resources can be really useful, and this is one place you could do that. So we've got our one EFS selected here, and now we can go ahead and click Resource Selection. That's kind of a funny named button because what you're really doing is confirming the resource selection that we just did. Now, because we were able to do the schedule and the resource assignment all in the context of that wizard, we haven't actually had the opportunity to go back and add any more rules to our backup. So before we're done, I'd like to demonstrate how that works by going here to Backup Rules, here in the summary of the entire backup plan, and we can click Add Backup Rule. So we can give a different rule to supplement the daily. We'll call it Monthly Backup. Keep the default vault. Switch backup frequency to monthly. And we can tweak these or leave them at default, but we'll transition to cold storage after 9 months, so we'll keep these around longer. And retention, we'll say we'll retain it for 2 years before anything gets finally deleted. Now you can click Add Backup Rule. So you can see how you can start to layer and build up your backup policies to give you just what you need. Okay, so now we've created this backup plan, but we don't really want to wait around in this demo for the schedule to kick in. So what we want to do is go run it manually. We'll go to the dashboard here on the side and click Create On-Demand Backup. Okay, so we've just had a problem. We've deleted some important documents out of our EFS file system, and we're here at the AWS Backup dashboard to see what can be done about it. The easiest way to get into our backups is to go to Protected Resources. Makes you feel very secure. Your EFS is protected. You can see here we have two entries. Remember that one of these was from the automatic backup that was offered to me by the EFS Creation Wizard. The second one is the one that we just created. And you can see I've got a couple of different backups here, including the one that I manually kicked off just a few moments ago. I can click on the radio button next to that and click Restore. Now I have the option for full restore or item level, so I could be specific about certain things I want to come out of this restore. I'll keep that at full, and I can either go to a directory in the source file system or a completely new file system. I don't want to have to go to the trouble of mounting a new EFS, so we'll just say restore to a directory in the source file system. The default restore role is fine, and we'll click Restore Backup. Now, this process may take a little longer than the actual creation of the backup did, so we'll come back in a few moments when this thing is complete and see what has happened. Okay, now the backup is completed. We've still got this bar at the top that says it may take several hours, but of course this is dependent largely on the size of the backup that's being restored. So we didn't have a lot of data to bring back, and it finished very quickly. Let's go back to the EC2 host and take a look at what we've got. If I do ls now, you can see I don't have my very important documents folder back, but what I do have is a new folder that's named for AWS Backup Restore. So we'll go ahead and go into there and take a look. And here we have, I'll make a little space here. As with everything, we're going to go back through what we created as a result of this demo and delete things to make sure we don't incur any unexpected charges. So let's go into AWS Backup. And we'll go to Backup Plans, and we'll try to kind of work backwards here. We'll click My Backup Plan, and the first thing I'm going to do is go delete these rules here. So Daily Backup, I'll confirm the name, delete it. Same for Monthly Backup. Oh, it's the last one on here, so it looks like I'm not able to delete that. Same, I'm assuming, for, no, not so much for resources. We can delete that there. So let's type EFS Demo Assignment and delete that. Now we will go up to the top here, click the Delete button, type My Backup Plan, and yeah, there we go, delete the whole thing. Now this backup plan, remember, if you happen to have that same as I do, is associated with the EFS. So I do not think that we'll be able to delete it until we delete the EFS, but we can try it. Go ahead and copy the name here, paste it in, and sure enough, okay, we're getting a permissions error because it's associated with the EFS system. We'll go into Backup Vaults. Now we do have inside the default vault one recovery point. See, that's the actual backup that was created, so we can go there, click its checkbox, go to Actions, and choose Delete. This is also one way that you could get to the Restore menu. So that's submitted for deletion. It will get deleted here in a moment. Okay, now that's deleted, and it should take care of everything that we created for AWS Backup. Meanwhile, I'm going to clean up the other resources that were part of this demo. Go into EC2 here, click on my running instances, and I will terminate the EFS that we logged into. Confirm that, and wait for that to go into a terminated state. Okay, now I'm going to go to EFS, and finally delete the file system. Here I called it EFS Demo 2, and I'll click Delete. I need to copy the file system ID in there. That does it for this course. We've seen the breadth of what AWS has to offer in terms of storage and data management. To go further, it's hard to find a more in-depth resource than AWS's own documentation at aws.amazon.com/documentation. Of course, there's plenty more AWS content in the video library of this site. I'd recommend Amazon Web Services Enterprise Security to learn more about IAM and access control. You may also want to check out Apache Spark Essential Training to help you better understand AWS Glue. And finally, you could go into one of my other courses, Amazon Web Services Deployment, Provisioning, and Automation, to learn how to get your applications to the cloud. Thanks for watching, and good luck as your journey to the cloud continues.